Hey everybody, this is 2.8. This is linear inequalities. So in this section, we're going to talk about much of what we just did with solving equations, addition and subtraction and multiplication and division, opposite operations to solve. We're just going to do a couple of additional things, including how we write out what we see. So sorry, there we go. A linear inequality in one variable is any inequality that's written in the form ax plus b is less than, greater than or equal to, or less than or equal to c. The coefficient of the variable x is always going to be not equal to 0. That's essentially the idea here, or else there is no x. If there are 0 x's, there's no point in writing it. So what we have when we look at these, the start is looking at solution sets. So when it talks about graphing the solution set of an inequality, we're talking about graphing on a number line. So when we see these things, we're going to draw a number line. We're going to put the important number in here. This is -1, and we're going to read the inequality. Here's the thing about this section. If you have a hard time figuring out what to draw or what to write, say them out loud to yourself. This is the best trick I know. Once you say it out loud and you read it, like truly out loud, and you're not just in your head, honest, I promise. It's going to sound crazy, but it works. Read what it says. It will help you figure it out. So in this case, this says x is greater than -1. So the solutions are all the numbers greater than -1. So when we graph linear inequalities, we use two sets of symbols. For less than or greater than, we use parentheses, okay? For greater than or equal to, less than or equal to, we use hard brackets. So this is a less than or equal to, or sorry, a less than or a greater than. In this case, it's x is greater than. So the answers are this way, which means I'm going to shade this direction and I'm going to use a parenthesis. That's all this is. So we're going to do the next one. This one says C is less than or equal to 7/3. So when I say that 7/3 is the number I'm going to put on my number line. C less than or equal to 7/3 tells me hard bracket. And when I think about where the numbers less than or equal to 7/3 are, they're on the left. So hard bracket to the left. You can start to pause the video and try some of these on your own. This one says 3 is greater than y. So I know I'm going to put a 3 in here. And if you want, you can switch that around because it's really, if 3 is greater than y is less than 3. However you want to think about this is okay. I know I'm going to use a parenthesis because it's a soft, there's no equal sign. The y is less than 3 are here to the left. This is essentially how this works. Let's try F. Let's do one more. 5 is greater than or equal to A. I can also rewrite that as 5 is less than or A is less than or equal to 5. So I'm going to put 5 on here. A is less than or equal to 5 are to the left. I'm putting zeros for some reason. Interesting. All right, so that's graphing. We can also graph solution sets that have two sides. So what this one says is y is greater than, I'm going to read this side first, y is greater than -4.1, and then less than or equal to -1.7. So I'm going to put those two numbers on my number line, -4.1, -1.7. Remember, -1.7 is bigger than -4.1. And I can see the y's are greater than -4.1, so they're over here, right? And they're less than 1.7, so they're in between these two numbers. That's where the answer is going to be. I'm going to shade that. And now I have to think about the brackets. This is just a parenthesis. This is a bracket, all right? And there's my graph. Let me try the next one. Y is greater than or equal to 0, or 0 is less than or equal to y, is less than or equal to 8.5. So I know my answers are going to be between 0 and 8.5. So I'm going to think about y is right between them. That's where I'm going to shade. And in both cases, I'm going to use brackets because the equal sign is there. All right. So when we use, this is called interval notation, basically. These are graphs. What we can do is really easily turn graphs into what we call interval notation. The endpoints we use in interval notation are always written from left to right, just like we would on a number line. We write from left to right. The smaller number is written first, a comma, then the larger one. We use parentheses when an endpoint is excluded from the set, so less than or greater than. We use a square bracket. That endpoint is included, so less than or equal to, greater than or equal to. And then we use parentheses whenever, so when you graph something, let's say from 3, numbers less than 3, and it just goes on towards the arrow, that's going towards negative infinity. Or when it goes towards infinity, those always get a soft bracket. So here are some examples. This is A is greater than something, so we're headed to the right. This is what the interval notation would look like. If we're headed to the left, it's headed towards negative infinity. That's what this, oh, I moved my, right here, okay? This third example, A and B are the endpoints, okay? This one, this would be something, X is greater than A, X is less than or equal to B. That's what this is, okay? And this one, in the third one, it would be something like that. And this one, in the second one, it would be X is greater than A. And this one, X is less than A. A's, oh, no, I did them backwards. Whoops. Pardon me, that's what I get for doing those on the fly. Okay, and you can just keep going and see how this works. This is what's called interval notation. So let's see what we can do. Set builder is this other kind of notation. So set builder is really different. We're going to do that in a sec though. So interval notation for this one, this graph is like from -3 to the left. So it's going towards negative infinity. And it starts at -3. Well, it's got, I can't see it because I drew over it. It's got a parenthesis, so that's what I'm going to use there. That's it. When we make set builder notation, that's what this is right here. The way you read this, it says y, where, so that big line says where, and then the inequality. So for the one we're going to do right here, set builder is x, where x is less than -3. That's it. All right, let's do this one. I'm going to draw my number line. I'm going to put just a -0.5 on it. So I see -0.5. There's a hard bracket there. And it's going towards infinity. That's all it is. So my set builder is going to be x where x is greater than -0.5. All the answers are greater than -0.5. All right, and then we'll look at the last one. It says y where -2 is less than or equal to y is less than or equal to 4. Well, let's draw that. -2, 4, y is between them. So it's a hard bracket here, a parenthesis at 4, and color in between. So then we're just going to use that for our interval notation. So there's a -2 and a 4. In this unit, you're going to have to graph quite a bit. You're going to have to use interval notation quite a bit, and you're going to have to use set builder notation quite a bit. So get used to them, start to practice. All right, so we're going to do set builder and interval for each of these. If you want to pause and try them yourself, it's not a bad idea, but go ahead. So this one is a hard bracket at -2 and going towards infinity. The set builder is going to be x where, let's see, x is greater than or equal to -2. I know that because of the hard bracket. This one is x is less than 3/2. And if you see it like this and it helps you to put it on a number line, do that. It's not a bad thing. So x is less than 3/2 are this way. Less than is just a parenthesis. So I know I'm going to have to go parentheses negative infinity because we do them left to right, remember? All the way to 3/2. That's it. And then the set builder is just x, where x is less than 3/2. All right, then let's try this last one. The interval notation is really just what you see from 3 to 1. And then the set builder, I need to write the inequality x where, let's see, -3 is less than x, which is less than or equal to, I know that because of the hard bracket, right? Less than or equal to 1. All right, so now let's talk about solving these. The properties that we saw before in the last section, adding the same to both sides, subtracting the same from both sides, these still hold, just like we did before. So nothing really changes yet. There is one thing that changes in a moment, but not much yet. So remember, when you see these, you're going to express the solution set in set builder and interval notation. So if we were just solving a regular equation, I would move the 5 to the opposite side. -2p less than -3p plus 1. I'm going to add 3p. And I'm going to get p less than 1. Well, it's done. So if you want to draw it, draw it. Otherwise, I know that the set builder or the interval notation goes from negative infinity to 1. And the set builder would be x, oh, sorry, p. Oops. P, where p is less than 1. That's it. You're done. Do the same for the second one. Add 5 to both sides. I'm going to get 2y less than y minus 6. I'm going to subtract y. I'm going to get y less than -6. So same thing. Y is less than -6, which means it's going to go from negative infinity to -6. And the set builder notation, x where, oh, y. It's twice I've done that. It should be y, where y is less than -6. That's it. So when we multiply and divide, the one thing that happens is if we multiply or divide by a positive number, nothing changes. But when we multiply or divide by a negative number, the sign, the direction of the inequality sign has to change. You learned this somewhere and you see it. You've seen it before. It's just that we have to remember it. If both sides of an inequality are multiplied or divided by a negative quantity, the inequality sign must be reversed every time, okay? So solve the inequality and graph solution set, express, oh, we got a graph this time. We might have supposed to graph the last time, but I might have missed it. Express in set builder and interval notation. Same thing we've been doing. So I'm going to add 3 to both sides. I get -5x less than or equal to 15. And then I'm going to divide by -5. That means I need to flip the inequality sign to the other direction. The answer is x is greater than or equal to -3. So I'm going to put that on a number line. X is greater than or equal to -3 or over here. It's a hard bracket. And then I'm going to put it in interval notation, heads to infinity, and set builder. X, yes, x this time, where x is greater than or equal to -3. Oop. All right, let's try the next one. -2 from both sides. -5p greater than 20. Divide by -5. Oh gosh, for some reason I wrote 2. I'm going to get p, and then I have to flip the sign because I used a negative to divide, is less than -4. Okay, let's put that on a number line. Put the -4. P less than -4 is to the left. it's a parentheses. So it goes from negative infinity to -4. And the set builder is P, where P is less than -4. Okay, that's the idea here. Okay, we're just going to keep doing that. Now they get a little more complex. So we're going to take it one step at a time. The same thing is always going to be true. You're going to express the solution set in set builder and interval notation, and you're going to graph every time. This is a habit you should get yourself into. All right, so let's see. I have to distribute and distribute. So I get 12 minus 2y minus 6 is less than -6y plus 3 plus 2y. I'm going to combine like terms. So on the left, I get 6 minus 2y. On the right, I get -6. Nope, I get -4y. Oops. Plus 3. All right, well, let's see. Combine, I'm going to add the 2y to both sides. So I'm going to get 6 is less than -2y plus 5 minus 5. 6 less than -2y. Divide by -2, which means I got a full, oh, sorry, not 6, 1. I have to actually subtract. I have to flip the sign, so I get -half is greater than y. Looks like I did something wrong. What did I do wrong? Let's see if I did all the math right. Oh, it's because somehow along the way I made my 3 a 5. That should have been a 3. This is why we check our work. All right, so that was supposed to be a 3. I don't know what I did there. -3 halves. Ay. Okay, so either way, now I'm going to pause. I'm going to draw on the number line. -3 halves is greater than y. So the numbers that are greater are to the right. So the interval notation is from -3 halves to infinity. And the set builder is y, where y is, oh, geez Louise, I'm just going to start over here. I didn't actually read that right. I didn't take my own suggestion, right? This says -3 halves is greater than y. And what I really needed to do was stop and think and not just follow the point of the sign. Because what that says is y is less than -3 halves. So let's try that again. -3 halves. Y is less than, so we're going to the left. That affects our interval notation. And then we can do our set builder up here, y, where y is less than -3 halves. You'll put the other bracket on there. I ran out of space. Okay. You try the second one. See if you can get it to work. I need to, my little menu came up over my screen and I can't, there it goes. Okay, the answer to the next one is x is greater than 5. You should be able to draw that, put it in set builder notation, and put it in interval notation. If you get stuck and you're not sure what to do, come on in and come into the discussion and ask about this one. All right. This looks crazy, but just like last time when we cleared through fractions, we can do the same thing here when we have different kinds of notation. So I'm going to look for the least common denominator. In this case, it's 12. So I'm going to multiply everything by 12 before I do anything else, including that 2. All right, so 4 goes into 12 3 times. -1 times 3 is -3k. 6 goes into 12 twice, plus 2. Less than or equal to 12 times 2 is 24. 3 goes into 12 4 times, so 2 times 4 is 8k. Now I'm right in a good place again. I can work. So plus 3k to both sides. I got 2 less than or equal to 24 plus 8, 9, 10, 11, 11k. So I'm going to subtract the 24. I get negative 22 less than or equal to 11K. I'm going to divide by 11. And in this case, I'm not going to flip the direction of the sign because I didn't divide by negative 11. I just happen to have a negative answer. And then I'm going to rewrite it so I can read it in the right direction. So I get K is greater than or equal to negative 2. Well, I'm going to draw that out. K is greater than or equal to, that's a hard bracket, goes that way. So my set builder, or sorry, my interval notation looks like this. And my set builder is K, where K is greater than or equal to negative 2. That's it. That's how these work. You should practice the second one. When you get to an answer, the answer should be T is greater than or equal to 30. You try it. See if you can make it work. I know that you can. Just be patient with it. All right, let's do one more. This one is a little different because this is a compound inequality. So in a compound inequality, we're basically doing two sides at once. It can help if you like cover up this half and just look here, right? And then you can almost do the exact same thing on the other side and sort of imagine covering up this half and just looking here. The difference is we're going to handle them both in the same time. We're just going to go two directions. So the first thing I would do in a regular equation is I'd add and subtract. So I'm going to subtract that 1 from all three places. And if it helps to draw some lines so you can see where you're going, that helps too. So I get negative 4 less than or equal to 2x less than 6. And I'm just going to divide in all the directions. I divided by 2, so I get negative 2 less than or equal to x less than 3. And now I can graph and do the interval in the set builder. So let's graph. I have a negative 2. I have a 3. Let's see, at negative 2, I have a hard bracket. At 3, I have a parenthesis. Answers between them. And then I have interval notation looks like this. And I have set builder is x, where x is, oops, negative 2 comes first. Negative 2 less than or equal to x less than 3. That's how they work. I'm going to move that set builder notation so that I can try this next one with you. So we're going to do the same thing. Imagine those lines if you need them. Plus 5, plus 5, plus 5. I get 2 less than or equal to 2y less than 6. Divide all three sides by 2. So I get 1 less than or equal to y less than 3. I'm going to do the same thing. Make the graph 1 and 3. Bracket there, parenthesis on the 3, color between. So the interval looks like this, 1, 3. Oh, 8. Why didn't I? Oh, why? How did I get 6? Another mistake. My apologies. This is a tough video today. So I did add the 5. And instead of adding in my head, I subtracted in my head. So 8, 9, this should be 16. So that should be 8. Forgive me. I'm just going to make them 8s. Oy. And then the set builder is y, where y, 1 is less than or equal to y is less than 8. Okay. So we have a couple of quick applications. Just remember that when you read these things, A is less than B. This is what it looks like. A is greater than or exceeds B. A is less than or equal to at most or no more than is less than or equal to. At least and no less than is also the same as greater than or equal to. So you have to listen for those words in your head. Write the English phrases. Claude's annual salary is no more than $40,000. So let's find that. No more than is less than or equal to. So his salary is less than or equal to $40,000. Okay, a citizen must be at least 18 years of age to vote. So A, greater than or equal to 18. An amusement park ride has a height requirement between 48 and 70 inches. H is the height, so it says between. H is usually between, it means included. Because if you're 48 inches, you can go on the ride, right? So it's between those two values. All right, you try these. Pause, actually do them. I'll put the answers here as you do that, and you can see if yours match. If they don't, what you should do is bring your questions into the discussion. That's where we will talk them through. Okay, all right, let's do one more thing. So there is an application here. To earn an A in math class, Alicia must have an average of 90 on all her tests. You've done this math before. Suppose she has scored 79, 86, 93, 90 on her first, and 95 on her first 5. Determine the minimum score she needs on her 6th test to get an A. Well, we know A is a 90. So the scores have to be greater than or equal to 90. And when we find an average, we add the things up and we divide by 6. But we only have 5 tests. So there's one missing. We're going to make that X. Her 6th test is what's going to be X. So we'll add up all the other scores, 79 plus 86 plus 93 plus 90 plus 95 plus X. Divide by 6 is greater than or equal to 90. Well, let's simplify this a little bit. Those numbers all added together get 443. So 443 plus X divided by 6 is greater than or equal to 90. I'm just going to multiply both sides by 6 to get rid of that denominator. So I get 443 plus X is greater than or equal to 540. I'm going to subtract that 443 from both sides. And I'm going to get X is greater than or equal to 97. So she's got to get at least a 97 on that last test to get an A on the class, in the class. If she doesn't get a 97, she gets lower than a 97. Anything lower than that, she's got a B. All right. In this case, it's exactly the same thing. You try it. I will tell you in the end, X in this case has got to be greater than or equal to 85. If you get stuck, come on into the discussion and let's talk about it. Use the example that came before this for help. All right, this is the end of 2.8. There is one more section for chapter 2 that comes after this that is not a numbered section, so keep an eye out for it. And go practice, go look at Alex. If you need help, you know what to do.